that is actually doing this course by internet this summer. Okay, so question here says to show all your steps, which you need to do. No credit for answers without work, and that is the way it is. Gary runs a food cart at the track. He has to collect 9.75% sales tax on all of his sales, but it drives him crazy trying to make exact change all day for all kinds of different crazy amounts. So we're going to assume that he wants to have the following charges to be the final as an after-tax cost of each item to his customers. Find the price that he should charge for each item. And I made comments to quite a few people that had turned theirs in early. Either, I had one or two people that were doing fine, but a lot of people don't apparently understand how to work this problem. It goes back to the very first lesson we had. The first thing I'm going to tell you is what you do not do is you do not multiply the percentage sales tax times the final price. You do not. That will give you the wrong answer, and that's what the majority of people were doing. Okay. On this, says he has to collect sales tax on all his sales. So, for example, let's see if I can get this kind of side by side here. Somehow this is very sideways. Okay, here's what happens. Gary's going to put a price on his menu. We don't know what that price is because it's asking us, what should he charge so that the final cost is $4 for that hamburger, including the tax? Now, what do you actually pay the tax on? I went and got my favorite guilty pleasure this morning. I went by Starbucks, grabbed my Grande coffee. The actual cost of the Grande coffee, if you have your own cup, is $2. But the final price of the coffee is $2.19. Why is my final price higher than the $2? What they add? Added sales tax. Did they charge me sales tax on the $2.19? No. They charged me sales tax on the $2. Okay? Now, I know walking in every single day that $2.19 is what my coffee's going to cost. But they've already added the tax to that. So his menu price is going to be like the cost of my coffee. You can think of that as the actual cost. So what happens then is when you go in and get the actual cost, they're going to add to it sales tax. And that sales tax to be applied, first of all, has to be changed to a decimal. Everybody's doing that right. But that's 9.75% of the actual cost. And that actual cost is 100% of the cost before tax. And this is the key. That's before tax. And the 9.75% is actually going to be multiplied times that before cost, not the after cost. So then what happens at the end is you get the after tax cost. And that word after is very important, because what you are given is not before, but you are given the after. So what we're going to have to do to solve this problem is we're going to take 100% plus 9.75%, and we're going to multiply that 100 and 109.75% and change to a decimal. That is 1.0975 times the before. This comes from the tax. This is because you're paying 100% of what the before was. And in this case, we've got the after. This is added because the actual final price went up. So you add to 100%. Okay? Now, if you want to talk about solving as an equation, you can, but it's easier to remember this rule. If you have after, if you have the after cost, you add or subtract and then you divide. What I'm going to do here is I'm going to divide both sides by 1.095 to cancel that out and have just the before as my solution, what you normally think of as X. In this case, it was $4. Don't need the last zero, okay? But I'm going to have to divide to solve the problem. Now, the reason I said add or subtract here, you add the percent if it's tax, okay? If they're adding an amount to get your after cost. If something's on sale, then you would subtract it from 1 rather than add it to 1, because they're actually taking money off, which is like the Amazon problem that I told you that they had it on sale for $59.99, and that was a certain amount of a certain percentage discount. What was the previous price, the original price? Then you would subtract. So if you have the after cost, after tax, after discount, you're gonna divide the number you got by the percentage. Either 1 plus that percentage if it's sales tax, or 1 minus that percentage if it's something on sale or a discount. Okay? Now, if you actually have the before, and none of these on this portfolio, by the way, were the before, it was all after. If you were to have the before, you're going to do the same addition subtraction thing here, but then you're going to multiply. So the thing to ask yourself when you go to the problem is, am I looking for the cost before they added something or subtracted something from it? Or do I already have that original price and I'm trying to figure out what my final price is? Those are the two things you have to look for. So for example, the hamburger, that's $4. I'll go ahead and show you how to work this one. Because it fits this pattern. The hamburger's $4. And that's $4 after tax. I know they're going to take the sale price, which is X, and add 100% to 9.75%. And eventually get a decimal number. That's 109.75. And I'm going to divide $4 by 1.0975. And the reason I'm dividing is because I have after. And when you do that, that tells you that your prior to tax cost should be $3.65. Now, if you want to see if that makes sense, you take that $3.65 and you do what you know that they're going to do when you pay for the hamburger. They're going to say, okay, that's $3.65 times 0.0975 will tell you the amount of the tax. And that was 36 cents. So then if you add 100% of the 365 to that 36 cents, you actually get 401, but that's because of rounding. Okay? Now, if you had done it the other way, this is what you need to think about. If you had thought that you were supposed to do it by multiplying 9.75% times the cost of the burger after tax, this is what it would look like. This is not the right way. You come up with 39 cents tax. And if it's 39 cents tax, then $4 minus that 39 cents gives you 361, and you think, well, okay, that's smaller, so that sounds right. Now here's the problem. If you have your pre-tax price of 361, and you multiply it by the 0.0975, because that's the way they actually calculate the tax, is to take 9.75% times the menu price. This is what you get. $0.35. Now, here's where the problem comes in. That would make the final cost of the hamburger $3.96, not $4. Okay? So if he followed that logic, which is the wrong logic, if he follows this logic, what's going to happen at the end of the day? He's going to wind up paying part of his customer sales tax, because he's basically undercharging the tax. Because he's not doing it properly. He's only charging 35 cents when he should be charging, I'm sorry, he's charging 39 cents when he actually should be charging 36 cents. So he's actually overcharging. I'm sorry, I misspoke there. He's actually overcharging.
Now, I got $3.64.
You're off like a penny or two, that's okay. Everything within 1 cent, one way or the other is okay. Okay. Did I maybe enter something out?
I think your settings on the calculator rounds it up.
Let me look, because you might be right. I didn't check to see what mode it was in. Yeah. Yeah, it should have been 64 cents. You're right. Yeah, I didn't realize the settings were messed up on the calculator.
Yeah, I thought we were crazy.
No, now, actually, it kind of puzzled me, like, I don't think that comes out to be 3 decimals. But, do you understand the process now?
Yeah.
Okay, that's the main thing. I want you to understand the process.
I think I just got confused because at the very start of it, when it's like, when you figure out if it's an increase or decrease, it's like, well, we're decreasing from $4 instead of,
Yeah, the wording's really confusing.
Yeah.
The wording doesn't make any sense. The last two sentences is what confused me. Because you don't really know whether that $4 is the fine, like, I don't know.
Well, the $4 is the final cost, but the way to read the problem and try to break it down is to try to determine, do you know the after cost, like after it's on sale, after the tax is added, after whatever, or do you know the original price, which is before? Really, the easiest way to think of this is before and after. So he wants his final cost. Basically what he's doing is he's trying to keep from having to make change. He doesn't want to have to count pennies. Okay? Same thing works for Susie. She's got $50 after she buys her groceries and pays the tax on it. She's got a total of $50. So when she walks up to the register, if they tell her it's $50.25, she's up the creek. She doesn't have any more money. Okay? So the cost of her groceries before the tax is added is what you're trying to find. And then you should compare, because you got two different tax rates here, In Kingsport, the tax rate for groceries is 8.25%. She goes to Weber City, the sales tax on groceries is 2.5%. Is there that big a difference if she's only spending $50? But you work the problem exactly the same way you did the ones on the previous page, or on the previous problem. What?
Just get refreshed
Yeah.
on those ones.
Okay. And the last one says Gerald wants to take Mitzi out to dinner, he has $45. Now, he does not want to go up to the cash register when he's done. And they say it's you know, with the tip and everything else, it's gonna be more than the $45 he has in his pocket. He doesn't wanna stiff the waiter. So he wants to give a 15% tip plus pay the 9.75% sales tax. So that means the total for Gerald is gonna be 15% plus 9.75%, which is gonna be 24.75%. Okay?
What is it then?
He's gonna leave a 15% tip, and his sales tax is 9.75%. The only difference on this problem and the ones that we did before, on 1 and 2, is that when Gerald walks out of the restaurant, this is how much money he's got. Okay? Or 45, sorry. So he can't go over that. So now here's what he's got to pay. He's got to pay the menu price. Which we don't know. Plus, he's got to pay a 15% tip plus 9.75% tax. So that's a total of 24.75%. And that's 24.75% of the menu price. Which is X. And since the tax is being added, the easiest way to handle that is to take 100% of the menu price plus the 24.75% of the menu price and multiply your menu price by 124.75. Oops, yeah, that's right. It's 124.75%. So when you change that into a decimal, since you're going from percent to decimal, you're going to move left, 1.2475 times the menu price. And that can't come up to be more than $45. And since what we have is the after, and we need the before, we're going to divide. And then that will tell you how much he actually can afford to spend on dinner. And he better be pretty good at his math, because what he's going to have to do is he's going to know what they can spend total, and if he's a gentleman and he's paying, he's going to let her order first, so he may wind up eating salad. Because he's going to have to adjust what he orders to stay within that budget. okay? Are there any other questions that I can help you with?
On that review,
Mm-hmm.
how did number 18, how was that cost?
Oh, yeah.
You'll get the review. Okay. Number 18 says 50% of the voters at a precinct are Republican. And 30% are in favor of a referendum. And the question is, do 15% of the voters that are Republican favor the referendum? And actually, looking at that, I may be with you. There may be a typo, but let me look. Okay. We got a whole bunch of voters. All of them, right? Out of that whole bunch of voters, 50% of those people are Republicans. And then it says, "30% of the voters total are in favor of the referendum." So this is 100% of all voters. So what that tells me, and this is always my favorite way to do this because the math's easy. If I assume I've got 100 voters, and 50% of those voters are Republicans, that means there's 50 Republicans. And if 30% are in favor of the referendum, then that means 30 people favor the referendum. So if these people are evenly split, basically like this says, between Democrats and Republicans, then 15 of those people are going to be Republican. And 15 are whatever the other party is. You know, there might be more than just two parties. So all the rest, we'll call them Democrats if you want to. But basically they're 50-50. So that means 15 Republicans out of the 50. Is that 30% of the 15 Republicans? If 30% of all the voters favor it, then 30% of Republicans should vote favor it, right? Well, that would be 15. So let me check the answer.
That's, I think the reason it's false is because I think it's based on an assumption. Like you have to make an assumption that's not implied in it. I give two value sets, so.
Okay, yes, because of the way it's worded, it says 15% of the voters are Republicans in favor of the referendum.
You know, how do you know that all of those voters are Republicans
Right,
that are in
right.
favor?
Right, the 50% and 30% are two different value sets.
That's right. That's right, and that's, this separation, sorry.
Yeah, it would be true if it said 30% of the Republican voters are in favor of the
Yes,
representative.
that's the difference. Because it says 30% of the voters are in favor, but you can't make the assumption that that 30% applies to the Republicans, because it's not Republicans in favor of. It only follows if you have a situation where it's like this. You have all your voters, and then you count out your Republicans, and that's 50%. And then out of those voters that are Republican, are they in favor of? But that 30% didn't apply just to the Republicans. It applied to all the voters. So that's why it's false. Okay? Be very careful in the wording. This one says 40% of the students in the class are men, and 10% of the men wear glasses. Okay? Same set. You take the men out and then say, okay, now 10% of these guys wear glasses. So that's men with glasses. In this case, 50% of the voters are Republican, but 30% of all, not 30% of the Republicans, but 30% of all the voters. Those that are in favor of the referendum may or may not be Democrat. They're just voters. The split's not necessarily going to be the same. Okay? Any other questions?
Okay, can we look at 19 and 20, part C?
Okay.
Because I got A and B, but I tried everything to get C.
Okay. Well, for part A, let's see if I can get this side by side again. For part A, you're going to compare Alexis and Peyton. But only week 1. So looking at that, Alexis met her goal with 162 out of 180. Because you're looking strictly at how many said yes out of how many people she actually talked to. Peyton, on the other hand, got 19 out of 20. Now, before you jump to too many conclusions, look at the disparity in those two sample sizes. Okay? So when I convert this to a percent for her success rate, I get 0.9. and that's 90%. Peyton, on the other hand, has 19 out of 20. She has a 95% success rate. So it looks like she did better. Then we have week 2. And we have Alexis and Peyton. And in week 2, Alexis got 10 out of 20, which is 0.5 or 50%. Whereas Peyton got 99 out of 180. So she had 55%. So again, it appears that Peyton did better. But then on the last one, we're talking about both weeks. So this is overall. So Alexis overall had 162 plus 10 that were yes, over 180 plus 20 that she contacted overall. So she had a total of 200 that she talked with, and 162 plus 10 is 172. Which is 86%. Now looking at Peyton, Peyton had 19 yeses the first week and 99 yeses the second week. And she had 20 that she talked with on week 1 and 180 in week 2. So she also had 180 plus 20. It was just 20 came first. Still a total of 200. And 19 plus 99 is 118. And 118 divided by her 200 customers that she talked to is 59%. So actually, overall, if you look at the 2 weeks together, Alexis did better. And this is an example of Simpson's paradox, where even though it appears in the 2 subgroups that Peyton did better, if you actually combine the 2 groups, it turns out that the other person in reality did better, and that's because of the disparity in the sample sizes. Because your total sample in both weeks was 200, but if you compare the 2 sample sizes to the members that are in the sample, you're giving too much weight to that one no. You're giving that Peyton had. And in the second week, Peyton's was a little bit more even. And in the first week, Alexis's her 18 didn't have much influence either. So you have to look at, overall success rate. So compare it, well, overall, she should get a raise, because that's a lot better success rate than 59%. Okay? Was that the only one, or do you want to look at 20?
20. C.
Yeah, just the last word.
Okay, same thing there. The overall death rates for each hospital. Well, Hospital A overall had 6 in good condition and 57 in poor condition. Out of 600 plus 1,500. And 600 plus 1,500 is 2,100. So they had a 3% fatality rate. Hospital B had 8 that died in good condition and 8 that died in poor condition. And their total was 600 plus 200 was only 800 people. And 16 out of 800 is only 2%. So Hospital A had the higher death rate. Even though if you looked at the patients in separate groups, Hospital B had the higher rate in both cases.
I have a question. Were we supposed to write it out like that on the test review, where it's supposed to be that?
You don't have to actually do that. What you want to do is just show me the if you had gone straight to this step, that would have been okay. But I actually put those in to help you track where those numbers are coming from. Okay? Anything else? Anything else? Okay. What we will do I'm going to talk to you on Wednesday about the portfolio for Unit 3. That one seems to be where people are having a lot of problems. If you go look on the discussion board, I copied and pasted the link there. They'll take you straight to, all you have to do is click on it on the discussion board. It'll take you straight to that page. What I'll do on Wednesday is, I do have several people in here that have already done that portfolio and done it correctly. You can figure out if that was you or not by going into Shelby, even though I've not graded the portfolio yet. If you see a gold star on yours, you're doing fine. Okay, and I may call on you to lead some groups to help them through the process. So I'm gonna give you some time on Wednesday to actually work on this in class so that I can help you. But what you have to do is you have to go to that website And then once you get there, you actually, see, I don't think I put the link to it. No, I didn't.
It says that the 403 is locked.
Let me change the setting. I may not have changed. It shouldn't lock until June 30th, which is Friday.
I don't know why mine's locked.
Oh, it does say that at the top.
Says what?
Said it's locked.
This assignment is locked, you can view it, but you can't make changes.
Okay, see if it'll let you in now.
I still need to go. And I think that we need to log out first.
You might, but usually it updates. Okay, let me go back here. Okay, try now. Yeah? Okay. I know what I need to do then. Just took me a minute to figure it out. Okay. Okay, you should be able to get in now on portfolio assignment 1. Check portfolio assignment 1, make sure you can get into it, please.
No, it's locked on mine.
Okay, check now. They should all be unlocked.
Yep.
Okay. They've changed the way you set some of these things, so it's a little tricky. It's going to show you, if I could find it. Once you get into that website, if you look around, there's actually a link to where you can find metropolitan and non-metropolitan area occupational employment and wage estimates for Johnson City. So you'll need to be able to go to that page too. And then there's also CPI data on here somewhere. that table 728, I don't think it's actually called table 728. But it'll take you to this page too. So we'll talk about that on Wednesday. I don't want to take away from time to take the test. It's 9 o'clock, that gives you an hour to take the test. Is everybody ready to go?